So today we want to look at how to differentiate by the use of the first principle. All right. So when we talk about the use of the first principle, it's just some rule that one of our mathematicians came up with. All right. So we want to look at how we can use that rule to solve a differential equation without using the power rule or any other method that you know. All right. So let's start. All right. This is our first question. Say y equals 1 over s squared. All right. So we want to use the first principle to navigate our way out under this problem. All right. So the first principle said this is the formula. All right. We have limit as h approaches 0, f of x plus h minus f of x over h. All right. So that is the rule for the first principle. So let's figure out this expression and that of this expression as well. All right. So f of x plus h is equal to what? How do we find f of x plus h? All right. That is very, very simple to do. All right. So from here, we can say that, or the same, we can say that our first principle is equal to lim as h approaches 0. This will be written as 1 over, wherever we see x, we add h. All right. So from here, we can see that s plus h all squared minus the f of x, which is this. All right. So let y equals f of x. All right, which is equal to 1 over s squared. All right. So from here, we see that this is equal to that. So this we have 1 over s squared all over h. All right. So from here, we can reciprocate this, and then we have lim as h approaches 0, 1 over h into 1 over x plus h all squared minus 1 over s squared. All right, that's the first principle. So we have to expand the bracket inside first. So from here, we can see that our first principle is equal to the lim as h approaches 0, this 1 over h into 1 over s squared plus 2sh plus h squared. All right, we expanded this in this bracket, and then that was the result it yielded, minus 1 over s squared. All right. So from here, you can easily simplify your inside, and then you have 1 as h approaches 0, 1 over h. This will now give us, when you simplify the inside, we can say that this will give us s squared minus x squared plus 2sh plus h squared all into brackets. All right, over the expression again. All right, we have over s squared into s squared plus 2s plus h squared. All right. So from here, we can now expand the bracket at the top. All right. So we can now expand our numerator, and then we have 1 over h s squared minus s squared minus 2sh minus h squared, all right, all over s squared plus 2sh plus h squared, all right. So from here we can see that this will take up this, all right, and then we have first principle is equal to the limit as h approaches 0, 1 over h into, now this is off, so we have minus 2xh minus h squared over s squared into s squared minus, all right, plus 2xh plus h squared, all right. So from here we can do simple factorization from here, all right. So from here we can say that this can give us minus, or we can say that this can give us h into minus 2x minus h, all right, all over h, all over s squared plus 2sh plus h squared, all in brackets, all right. So from here this can take off this, all right. So we have first principle is equal to lim as h approaches 0, then minus 2x minus h over s squared into s squared plus 2sh plus h squared, all right. Very, very simple. So from here we can now do some simplification from here again, and then we can say that our first principle is equal to the lim as h approaches 0 minus 2s minus h over s squared over s squared, all right. So from here we can now go ahead and then substitute the value of h into the expression. So as h approaches 0, we say that first principle is equal to minus 2x, all right, minus 0 all over s squared into s squared plus 2xh, where h is 0, all right, times or plus 0 squared, all right. So from here our first principle is now minus 2x over x into s squared, all right, because this will give us 0, this also will give us 0. So we have the first principle is equal to minus 2x over x power 4, all right. So from here you can see that from indices you can see that this is having the same basis and therefore they are dividing. So we can say that we can subtract the exponent, all right. So from here we can say that we have minus 2 over x power 3, all right. So our first principle, from the use or from the rule of the first principle, this is now yielding us minus 2 over s cubed as our final answer. Very, very easy. It's very easy to navigate your way out on this problem, but what you must also know it is that when you have such a problem involving fraction, all you have to do is that make sure that you manipulate your f of x plus h very well. Other than that, you get it wrong, all right. So from here you know that x plus h. When you have something like this, wherever you see x, just add h. Alright? Wherever you see x, then add h. Right? So that's what basically we've done over here. And it's resulting as minus 2 over s cubed. Alright? And this, to verify whether this solution is correct or not, you can go ahead and then use the power rule along somewhere, not on your work paper, somewhere, and verify that if you know that if you have 1 over s squared and you want to use the power rule, this is the same as x power minus 2. Alright? So differentiating this, we have minus 2x power minus 3. Alright? And this can be written as minus 2 over s cubed. Alright? So you can easily check your final answer using the power rule to verify your solution. So this is what the final solution would be. Very, very simple. Thank you very much. I think I have to give you some more questions under the limits. So let's look at the next problem. I know you are enjoying the lesson, right? Very, very nice. It's so easy to navigate your way out under this topic. So let's look at our next problem using the first principle again. Using the first principle again, said y equals root of x. Alright? Y equals root of x. So y equals root of x, we can let our y equals what? F of x. And then this will be equal to our root of x. First, state your formula. State your formula first. And that will guide you to navigate your way out to a final solution. So from here, we can say that the first principle is equal to limit as h approaches 0, f of x plus h minus f of x over h. Alright? So what we do is that wherever we see x, we add h to the expression. Very simple. So from here, we have the first derivative is equal to the lim as h approaches 0, and then x plus h, root of that, alright, minus root of x, all over h. So from here, if you try, it's the simplification rule before you substitute is in limits, alright? If you try to substitute the value of h directly into this expression, you end up messing up, alright? So first, make sure that this expression is simplified into or to the lowest term or to the simplest form before you substitute the value of h as it approaches 0 into the expression. So from here, we can say that this is an expression that is exhibiting a rational, or we can use the rule of rationalization to simplify this. Alright, so we can use the rule of rationalization to simplify this. So we have to simplify this further, and then we have root of s plus h minus root of x over h. Alright, the rule of rationalization said if it's negative, it changes to positive, all right? So we have times root of x plus h plus root of x over root of x plus h plus root of x. All right, very, very simple. So from here, we can go ahead and say that our first principle, lim as h approaches 0, from here, you can see that this is exhibiting difference of two squares, all right? So we say that root of x plus h minus root of x can be all squared, all right? So from here, or we can say that this all squared, this 2 all squared, all right? So from here, over root of s plus h plus root of x or h, all right? So from here, we do our necessary simplification, and then we can say that first principle or first derivative is equal to lim as h approaches 0. From here, we can say that this, when you simplify this very well, you have x plus h minus x. Simplify this very well. This will cancel the square root sign, and this will also cancel the square root sign. So I have x plus h minus x. Very, very simple. So from here, we can also say that this will give us, now we maintain this, we have s plus h plus root of x. All right? So from here, this will take off this. All right? So we have first principle or first derivative as h approaches 0, h over h into root of x plus h plus root of x. All right? From here, you can see clearly that h will take off h. All right? So root as h approaches 0. All right? Now we have 1 over root of x plus h plus root of x. All right? From here, we can now go ahead and then substitute the value of h into the expression, because now we have simplified the expression into its lowest term. All right? So you don't have to go ahead again and simplify again. Now we don't have anything to do here anymore. So now what we need to do is that as h approaches 0, we have 1 over root of x plus 0 plus root of x. All right? So this now yields 1 over root of x plus 1 over root of x. All right? So this gives us 1 over 2 root of x. All right? Very, very simple. You know that 1 is here, we have 1 here, and we have 1 here. So this plus 1 plus 1 will give us what, 2. And they are all having the same root. So we have 1 plus 1, and that gives us 2 root x. All right? So that is basically what we mean by that expression. So this becomes our final answer. 1 over 2 root of x. All right? So limit as differentiating root of x as h approaches 0, that is our final answer. All right? So therefore, y equals the differential of this with using the first principle is now yielding us 1 over 2 root of x. Very, 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 very simple. just understand the principle, and then it will guide you on how to navigate your way out under such problems. All right. So first, when you are given such a problem, all you have to do first is that state your formula. All right. State the rule of your first principle, and that will guide you to how you can go about the question and then come out successfully. All right. So after that, or before you solve the question, or before you work out the problem, first you can decide to use the power rule. All right. The power rule, which says that if you have root of x, you can have this is the same as x power half. All right. And this, when you use the power rule, you can say that this, we can bring the half in front. All right. Bringing the half in front, then we subtract 1 from this, and that will give us minus half. All right. And this result is the same as 1/2 root of x. All right. So before you use the first principle, if you are not very sure of your answer, you can use the power rule to verify your solution before you go ahead. All right. So thank you very much for watching this video. I really appreciate your kindness for watching my videos. Please don't forget to subscribe as well. Share to others to also benefit. Thank you very much for watching. Bye.